Hello, this is Britt Caswell with another example video. In this example, we are looking at section 1.6, example 1 in the Algebra 1 SavvasRealize textbook. Here we are looking at understanding compound inequalities. So first I want to describe what a compound inequality is. So first let's think about English class. If I have two words, such as do and not, I can create a compound word by kind of mashing these things together and calling it don't, right? That's what we mean to compound in English. In math class, we do the same thing. So we might have like x is greater than 1, and we might have x is less than 7, and we can compound them together to create a single inequality that's kind of like a chain. All right. Now there's two kinds of compound inequalities. There's and, meaning that the solution that we choose has to work for both inequalities. So in this top part, a number greater than 1 and less than 7. So like 5 would work in there, right? Okay, and inequalities tend to graph kind of like a Q-tip or a barbell, maybe a used Q-tip, something shaded in. Ooh. Okay. An or inequality tends to be graphed by two arrows facing in opposite directions. Sometimes you might see it grouped up like this, but usually for or inequalities, they'll have it more like this, where they have two inequalities separated by the word or. They don't tend to compound it in the same way with making a single number sentence. But if they do, they just flip the directions of the inequality symbols. So let's take a look. So example A here is an or situation. You see how neither of these graphs overlaps? So if they were asking me specifically about a solution that works for both of these inequalities in an and situation, you'd say there's no answer because it doesn't overlap. So this one will be an or inequality. So what I do is I just create the equations, or the inequalities, just completely separately. So let's look at this left-hand one. I know I have an x, I know I have a -3 because that's my endpoint. So because I'm shaded to the left, I have x is less than -3. Then I look at the endpoint. The endpoint here is shaded in, so that means it includes that -3, so it can be equal to. So make sure to put that little bar underneath your inequality symbol. On this right-hand one, I know I have an x and I know I have a 2. Now this one is shaded to the right, so I'm saying x is greater than 2. And then because the endpoint is hollow, I don't put the little bar. So these inequalities are two separate inequalities, and it's impossible to have an and situation because they don't overlap. So this is going to be an or. So I say x is less than or equal to -3, or x is greater than 2. Let's take a look at B. So B here is an and situation. And we usually deal with an and situation by writing inequalities like you see up here. So I know I'm going to have less than x less than every single time. So the numbers on the outside are the numbers of my endpoints. So I'm going to put a -4, and I'm going to put a 1. And you always do it from smallest to biggest, okay? And then we're going to look at the actual endpoints to determine if they can be equal to. So if you notice, the endpoint here at -4 is filled in, so I'm going to go ahead and put a line under there for equal to. But the one at the 1 is not filled in, so I don't put a line under there. Now some people, this is how we usually do it, but some people might break this into two inequalities and just separate it by an and, like that. That's okay as well, but usually if we talk about a compound inequality, we usually want this bad boy right here where they're all combined. Let's try one more. So again, this is that barbell shape, which means that the solution has to work for both of the inequalities. So it's an and situation. So I put less than x is less than. I fill in the endpoints. So I have a -2 and a 6. And then I look to see if they're shaded. So this one is hollow, so I don't put the line here. This one is shaded in, so I put the line. And that's it. That's how you write an inequality given a graph. Until next time.